Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a second problem where you are going to find the equilibrium partial pressures of a reaction. But in this case you're going to be given only the initial partial pressures of your reactants and products, and you're given the Kp value. In this case, the Kp value, let me double check to make sure that is correct. It's the same Kp value. So in the last video, or last example, I had the exact same reaction with the same Kp value, but we've changed the amount of the reactants and products. So this time we are beginning with 0.150 atmospheres and 0.150 atmospheres, and we're only going to have zero pressure for the products. We have no product. So again, the first thing you want to do is find your Q, your reaction quotient, and you're going to compare that to Kp. So setting up your reaction quotient is the same as setting up your Kp expression. You're going to write Q is equal to the concentration or the pressure of ICL to the second power. So we'll do ICL squared, and these two, the pressures of these two multiplied together. So we'll have the pressure of I2 multiplied by the pressure of Cl2. And so we're going to plug in our values, but right away what you'll notice is we have 0 for the product and 0.15 or 0.150 squared for the two reactants, and obviously this is going to be 0. So Q is 0, which is much less than Kp. So therefore, that is telling us that, of course, we don't have any product, and so we need to form product to get this larger. So we could have guessed that without having to do Q, because the reason we find the Q, which is the reaction quotient, is to figure out where the change is going, which direction is the change going. And the reason that's important is because we want to know whether the change here is negative or positive, and whether the change here is negative or positive. And that's going to depend on the direction of the movement of the reaction. Okay, so with that, now we need to figure out what the change is. So we know it's going to go in this direction, so that means we're going to lose reactants and we're going to gain products. And so that means we're going to have a positive, or I'm sorry, we're going to have a negative change here, and we're going to have positive change there. So we're going to add to this and we're going to subtract from these two. So now what we do is we have to figure out, how do I say this? We have to have some sort of holder for this change. We don't know what the change is. That's what we have to figure out. So we're going to put X for change, and since we're going to use our stoichiometry to figure out how much change in terms of the unknown X. So we're going to use our mole ratios to figure out how much of X is lost and gained. So here again, the coefficients are 1 and 1. So we're going to lose a certain amount called X. And so since this is a 1-to-1 ratio, we're going to lose the same amount of X here. So here we're going to lose X for each of our reactants, and then we're going to gain 2X because the relationship between these two and this one is 1 to 2. So if we lose 1X here, we're going to lose 2X. We're going to gain 2X here. And again, this is positive, so it means we're gaining product. So this is how much product we'll gain at when we reach equilibrium. So So now we're going to add these together to get our equilibrium pressures. So this is going to be 0.150 minus x. This is also going to be 0.150 minus x. And then 0 plus 2x is 2x. Okay, so now we have our equilibrium pressures in terms of x. Now all we need to do is plug these into our Kp expression. And so the way we do that is the same way we set up for Q. So Kp is going to be equal to, again, the pressure of ICL squared over the pressure of I2 times the pressure of Cl2. Okay, so now we're going to take our equilibrium expressions here, plug them in. We've got our Kp value, we'll plug that in, and then we're going to solve for x. So you put these in, okay? So that means we have 2x squared on the top. And since both of these are the same, and when they're multiplied together, this is going to be squared as well. So we got 0.150 minus x squared. So the great thing here is that we can get rid of this. Oh, by the way, this is going to be equal to Kp. Since we have Kp, this is 81.9. So we have 81.9. And since we have square here, we can take the square root of this to get rid of the x, or get rid of the square. So we can take the square root of this. That'll get rid of the squares. And we'll have to take the square root of this as well. So then let's use our calculator. So this is 9.049. So then this becomes 2x over 0.150 minus x, and that's equal to 9.049. 9.049. And then at this point, you're going to use some algebra. You're going to multiply both sides by 0.150 minus x, and then get x on both sides, and then solve for x. So here we're going to multiply both sides by 0.150 minus x. Multiply this side by 0.150 minus x. We're going to multiply this out. This becomes, let's see, what is that? Times 0.15. So 1.357. So this becomes 1.357. And then this is going to be minus 9.049x. And then so this cancels out. We have 2x. So this is equal to 2x. So then you're going to add 9.049x to both sides. 9.049x. And so you add these together. If we add these together, that's going to be 11. Let me get another marker. This one's going. So we have 11. Oh, that's much better. 11.049x is going to be equal to 1.357. And then you divide both sides by 11.049. 11.049. And then you get x. So x is 0.1228, 0.1228, and so that would be x. And so then what you do is you put x in for here. So 0.150 minus x, which is going to be 0.1228. Okay, so you subtract that. So 0.150 minus equals, and you get 0.027. So that's 0.027. So you get, that's the equilibrium partial pressure of I2. Since these are the same, this is also going to be the equilibrium partial pressure for Cl2. And then if you multiply these together, so you get, this will be 0.054. So that would be the partial pressure of ICL at equilibrium. And so again, that's how you solve this sort of problem. Again, it's the same way whether you're dealing with partial pressures or if you're dealing with concentrations. If you're given only the initial concentrations of your products and reactants, and you know what the Kc or Kp value is, then you have to use your ICE chart to figure out how to figure out what X is, what is the change, and then plugging that back in. I hope this is helpful. If you like this video, please like, share, subscribe, and hit the notification bell. Thanks for joining me, and I'll see you next time.